I'm Sam Turner, the CTO of the High Value Manufacturing Catapult. The High Value Manufacturing Catapult, for those who don't know us, we're a network of manufacturing innovation centres, 7 centres distributed across the UK. We're here to support the UK manufacturing base, driving productivity and growth through manufacturing innovation. I'm going to talk to you today about net zero manufacturing, an important topic for the manufacturing community as a whole, and certainly for HVMC. We're going to start with the UK pledge and legislation to be net zero by 2050, carbon neutral. And this quote is from Chris Skidmore, who signed the agreement in 2019. So recognising the UK's role in the first industrial revolution and our responsibility for the growth, economic growth and increasing emissions globally, is framed not only the need and ambition for us to get to net zero, but also recognising the role it can play in driving the economy, seizing economic opportunities of becoming a greener economy. And that's one of the things I'm going to draw upon today, where those opportunities lie and how we can prepare for those. This chart shows a breakdown of UK territorial emissions based upon a Bayes report from 2017. And you can see broadly the emissions are broken down to transport, industrial emissions, that's from buildings, power and other. And manufacturing clearly covers the bulk of those industrial emissions, and also arguably some of the transport, buildings and emissions from other sectors as well. So UK industrial emissions account for somewhere between 15%, or if we actually accommodate also consumption emissions, so that's manufactured goods consumed in the UK but manufactured overseas, then those manufacturing emissions associated with the UK can go up to 30%. So it's a large part of the national challenge in addressing net zero. So I want to explore how do we address that collectively, and what does it mean in terms of opportunities for manufacturing businesses? If we think about the challenges that manufacturers are facing this year, maybe net zero isn't the number one priority right now. Thinking about how do we build resilience into our supply chains, how do we stay alive with uncertain demand signals coming from our customer bases, some sectors seeing huge upheaval and some seeing real growth potentially. But net zero, I believe, is part of that growth opportunity in terms of the sectors we serve, but also could become a competitive advantage alongside increased productivity and agility in winning new market share. So the engineering challenge. Engineering community and manufacturers will deliver many of the solutions to the net zero challenge. So legislation will have its role to play and policy, but clearly we're going to need clean energy, decarbonised transport, sustainable buildings and sustainable manufacturing. That requires real engineering solutions as an opportunity for increased UK content in delivering those solutions. And in the manufacturing in particular, looking at how can UK manufacturers become a destination for sustainable manufacturing, competing on evidenced sustainability and reduced carbon emissions. So we need to think about the products that we make and the way that we make them being sustainable and actually providing growth opportunities as opposed to an additional challenge to the manufacturing community in the UK. So this is a great opportunity that's presented to us by the legislation that is put in place. So I'd like to think about a supply chain perspective, first of all. And I mentioned the distinction between territorial emissions and consumption emissions from overseas. So currently, in terms of our net zero legislation, consumption emissions, so those that relate to our total consumption, but emissions that are experienced overseas are not accounted for in net zero legislation. So we look at the difference between those extreme scenarios of 15 to 30% emissions related to manufacturing. If we account for emissions from manufactured goods consumed in the UK, our total emissions are much greater. If we don't, then we're nearer the 15% total emissions for the UK for a manufacturing industry. Of course, the risk is one way of reducing our manufacturing emissions is to offshore them if our offshore emissions don't count. So this does raise a challenge around unintended consequences, that actually there could be a natural leakage of manufacturing overseas if our overseas emissions for consumption in the UK are not accounted for. And actually, we could see supply chain offshore in a declining market. Equally, we'd expect, in the short term at least, there to be some cost of innovation to build net zero and sustainable manufacturing solutions. And we've seen over past decades, manufacturing again shift to regions of the world where those standards and relating to emissions and the environment are not as strict. So how do we make sure from a national perspective that this is an opportunity and not a risk to UK suppliers? If we can account for supply chain emissions in the right way and actually track them through a dynamic supply chain, and OEMs are held accountable for those, and as a nation we recognise a standardised accounting measure across the UK industry, and seek agreement with some of our international trade partners, then we can see that competing on sustainable manufacturing agenda and evidencing our low emissions or net zero emissions over time for UK manufacturers becomes a competitive position for the UK. So this accounting method is key, that is recognised and understood and becomes a norm across sectors and is recognised by national governments. To account for domestic and overseas and supply chain emissions, we need an accounting standard that means we can digitally track and trace emissions as well. So one thing is agreeing those standards, but looking at how might we manage those in real time. So we can look at nominal emissions for a supply chain. If we imagine this rather generic breakdown of a manufacturing end-to-end supply chain, starting with the linear supply chain that we would normally work with. And you might argue that for an engineering subcomponent manufacturing process, let's say it's a casting process, there's a nominal emissions associated with that. But of course, caster A in one nation versus caster B in another could have very big difference in terms of their associated emissions, depending on the technology they use and the investments they make to reduce energy consumption, material consumption, and use clean energy sources. So we need to be able to measure and track emissions through a supply chain in dynamic terms, evidencing the real emissions from any given company. And this would provide an opportunity for mid-tier manufacturers to demonstrate a competitive advantage through their reduced manufacturing emissions. So this chart shows an example for a whole range of sectors of the normal life cycle, from raw materials extraction to processing to component manufacture to sub-assembly to full assembly, through life operation and end of life. And then showing some of the circular economy, the feedback we'd have from reuse of materials into materials processing, recycling components into re-engineering and subcomponent manufacturing, and ways of using waste streams for heat or raw materials. So this end-to-end life cycle helps us focus in on where we can make those interventions and where we can really compete, as well as articulating where we need to track the emissions through every step of that life cycle. So for example, having a fully net zero assembly facility is probably only a small fraction of the total embodied emissions for a product, just for its manufacturing life cycle, if we don't account for raw materials extraction. Now this draws us more closely to looking at materials that can come through this reuse cycle and looking at how do we build and manufacture our products, design and manufacture our products based upon material use wherever possible. So what are the solutions? If we recognise this problem and opportunity, how do we attack each of those boxes in that supply chain cycle we've just seen? And what are the interventions we can make and the steps that companies can take to start to evidence that they are working towards carbon neutral and actually start to compete in terms of differentiating on sustainable manufacturing? So at HVM Catapult, we've done some extensive studies to look at good practice nationally and internationally and understand what some of those interventions could be. And these are some of the common cross-cutting sector themes that we see. Of course, food and drink is very different to aerospace, but some of these factors cut across a range of those sectors. Resource efficient production is a huge part of this, and that could be material and energy efficiency in the manufacturing life cycle, but also influencing the design phase. So design for circular economy and net carbon zero is a really crucial part of the overall life cycle, an opportunity to drive towards net zero. Digitalisation, of course, this big digital manufacturing we believe plays a huge role, both in terms of tracing and tracking and evidencing and giving us the data that informs us to make the right decisions around reduced material and energy consumption, but also to put the solutions in factory that enable us to automate, optimize, and configure for reduced energy consumption and reduced wastage and scrappage as well. Resource management's a key part of this, looking at redesigning of business models, developing new materials and technologies and infrastructure. So that's new recyclable materials and new methods for recycling materials that currently exist. All of these areas present new business opportunities for engineering firms and manufacturing firms. There's also, beyond the manufacturing life cycle, the Throughlife Engineering and in-use elements. Now, this is very much locked in design as well, but it does start to create new opportunities for the way we design and manufacture products, and I'll come on to this in a moment. So if we look at resource efficiency in manufacturing systems, there are three major interventions that we would recognise. One is improving manufacturing processes with technology. Another is to use clean energy. So that could be electrifying our manufacturing processes and then building nationally a sufficient clean electricity grid system, but also looking at where we use heat, moving away from hydrocarbon-based heating into clean or electrified energy sources. And using low impact materials, so materials that are recyclable and don't have a huge impact in terms of extraction and emissions phase or processing phases. So recycling, digitalisation can help with new manufacturing technologies. Biogas, solar, wind and hydro energy can all have a huge impact on the clean energies. And then renewable biomass, recycled materials are an opportunity on that bottom corner of the triangle. So continuing with resource efficient production, use of sustainable manufacturing technologies and pathways. This could include things like energy harvesting, or digital systems to optimize energy usage in the same way we'd normally optimize for cycle time or without compromising quality. Looking at pollution prevention, carbon capture storage, continuous measurement and improvement, both at the design stage and the process execution stage for a given manufacturing process. Digitalisation and automation, I believe, is a huge part of the solution. It can improve quality, reduce wastage, but also enables us to optimize for energy and material consumption. So clearly adopting renewable sustainable sources of energy and renewable sustainable materials and looking at effective land use are really important. And the land use is a big part of the overall food manufacturing life cycle. So we look in particular at digitalisation and what are the opportunities for digital and sustainability. We believe this is a huge part of the answer. Now, we recognise there is a challenge around actual emissions. If you see a picture of a server room, which is not in itself carbon neutral. So digital doesn't come for free, but it can help us to drive down emissions throughout the whole life cycle at the design stage, and certainly in factory and through supply chain logistics. So life cycle assessments are generally using digital platforms now, becoming more sophisticated to help us make the right decisions at the design stage that impact on manufacturing, through life and end of life. Resource efficiency at factory level using AI, IoT, smart supply chains, again using AI solutions, drone usage, virtualizing products. So actually reducing emissions in life by having virtual products that actually have lower emissions. Looking at resource efficient manufacturing processes such as 3D manufacturing, 3D printing, or near net forming of composites, metallics, polymers that reduce material wastage. There's a terminology used in aerospace manufacturing that relates to buy to fly, and this relates to the material stock required from which the actual finished component is formed. And often that can be in the region of 20% of the weight of the initial stock material is actually the material that goes into flight. So looking at processes by which we can reduce that waste material, whether it's recyclable or not, and reduce the energy associated with processing it. Industrial symbiosis around markets and clusters is a big opportunity as well. Looking at addressing the skills requirements around net zero as well through training and immersive technologies. Looking at secondary markets and traceability of materials throughout first and second life is a big digital opportunity. And then asset monitoring and prediction systems, both for manufacturing products, but also for through life, again, predicting when failures will come and building stock to address failures in service or even to upgrade failures, product in service. So remote preventative digital healthcare can reduce demand, reduce emissions, as an example for the healthcare sector. So resource efficient net zero carbon factories. There's three ways we look at this, looking at the imports to the factory, which is about materials and energy. Operations, in terms of utilities, water, energy intensity, and also what we put out of the factory in terms of the water and air pollution that we release. And also the products that we make and design and deliver in those factories, making sure they're recyclable, renewable, and all the time and minimizing waste and energy consumption during that manufacturing life cycle. So developing new production systems, adaptation of existing production systems can help us drive the resource efficient manufacturing agenda, automation, digitalisation, and intelligent systems that optimise, so it's again, for energy and material usage alongside optimising for productivity and lead time. So the secondary raw materials market will become a big growth opportunity, especially if we can start to trace and evidence the previous life of raw materials and goods and assets, enabling them to be reused and recycled with their inherent value. It requires a bit of an openness and changing the way we think about research development and pilot production lines, but ultimately looking at converting waste into new value streams, reducing extraction of finite raw materials, reducing emissions and energy consumption. This all builds an economic resilience at a national level, as well as providing opportunities for businesses that can provide value propositions that address these needs. And we believe the industrial Internet of Things will be a key enabler, along with digital technologies such as potentially blockchain for tracing and evidencing emissions through the life cycle of a supply chain, and also the attesting for the verification and quality of raw materials and components for second life. So Throughlife Engineering I've mentioned a couple of times, and this is perhaps extending beyond the conventional manufacturing life cycle. But if we look at the solutions that were put up in the earlier slides around the engineering technologies required to deliver net zero, so energy, wind, nuclear, transport systems such as next generation electrified automotive fleets, or rail, or aerospace, these are all high value assets, where a Throughlife Engineering approach, where we design a product for its full life cycle, not just designing for a point of sale, mean that we can look at life extension, reduce consumption of energy in the manufacturing and the in-service life phase, and effectively mean that the manufacturing emissions become a smaller part of the life cycle emissions through life extension. So to do this, we need to have digital tools again to be able to monitor, predict, and build models that help us, robust models that help us predict life cycle, and even possibly to upgrade a product throughout its life cycle rather than just repair. And when it does come to decommissioning, it means that we can trace the experience of those components and repurpose them. So I'm talking about net zero carbon here, and occasionally we slip into circular economy and sustainable manufacturing. These are three very closely related strategies that are not absolutely the same. They have slightly different objectives. Circular economy is a way of driving resource efficiency, and net zero carbon is particularly about carbon emissions. But there are some common approaches, and we've done a review of existing roadmaps nationally and globally, and look at some of those common approaches. So these provide areas where we know businesses, sector bodies, consultancy groups are advocating investments to be made and opportunities to decarbonise or drive circular economy. So looking at the right-hand side here, we see decarbonisation of energy supply is a huge part of the solution. And that's not perhaps in the remit of manufacturers per se, but making sure that the processes we convert to can use clean energy and decarbonised energy. So switching them to renewables, etc. Electrification of energy supply and transport systems. Decarbonisation of production processes, so materials and chemical processing in particular, looking at carbon capture and storage in the industrial environment, heat recovery systems, energy efficiency, and building clusters, industrial clusters, industrial symbiosis to assist with switches to alternative energy sources and sharing of energy resources. So waste products from one factory or producer being an input source to another manufacturer. And process and product design are a crucial part of this. And on the circular economy side, there's other factors that are high on the agenda at the moment, looking at reduction of plastic packaging and food waste challenges, keeping materials and products in use, and designing for repair, reuse, refurbishment, disassembly, remanufacturing for the whole life cycle. These all prevent new business opportunities. And as we emerge back from the COVID world, we're going to see growth in these sectors, where we may see a relative decline in others that were booming before the COVID world was entered. So there's a real opportunity with the legislation we have in place for net zero emissions for 2050, for the UK to become a global destination for sustainable manufacturing and a net technology exporter. The UK has been in relative decline of its manufacturing base this millennium over the last 20 years, slipping down the rankings, and also a big decline in our manufacturing technology exports, where we export around 1% we own about 1% of the total manufacturing technology market. So for manufacturers looking to deploy technology that delivers a more sustainable, or ultimately a net zero manufacturing base, there's a great opportunity to compete and win business globally from those sectors and OEMs globally who are sensitive and need to evidence that they are too delivering across their full manufacturing supply chain net zero emissions. But also for technology providers, there's an opportunity for those from digital or physical background, cyber physical systems, to develop new manufacturing solutions in the UK that drive sustainability. And we can become not only the manufacturing technology community that supports and underpins our manufacturing base domestically, but a real exporter of solutions globally. So where to start? So the HVM Catapult and the wider Catapult network can support businesses looking to decarbonise. We can support on design for Throughlife and Throughlife Engineering, on material selection, on development of new materials, on resource efficiency in factory optimization, traceability, but also supply chain logistics and supply chain optimization. Digital technologies will be a huge part of this. Traceability of materials and goods and embedded carbon, we believe new solutions will need to be developed, and they perhaps could be led from the UK. Net zero carbon factories will be delivered ultimately through digitalisation, with optimising for net zero. And business models built on life extension and servitisation will provide great opportunities, we believe, for UK manufacturers, engineering firms and technology providers. I'd like to talk a little bit about digital innovation hubs. So this is something that's been launched currently through the Manufacturing Made Smarter ISCF programme. So Made Smarter innovation hubs are really trying to drive this growth of manufacturing technology innovation and adoption for manufacturers, and also drive growth in manufacturing technology provision. And they have three principal functions. One is as a technology test bed for technology providers to test, develop, and showcase solutions. Secondly is a demonstrator, showing where technology solutions can address real industry problems, not technology push, but looking at problems that are faced by companies on a sector basis or a manufacturing process basis, looking at green energy, solving problems, and where the technology can address those. And then a sandpit environment where companies can quickly configure projects to rapidly innovate, develop, and de-risk solutions before deploying into their own factories. So there's a pilot currently that's been funded through the Manufacturing Made Smarter ISCF programme that's been launched with the HVM Catapult on smart factory hubs. There's also going to be a pilot launching on supply chain as well, which will address some of the challenges around logistics related emissions. There's going to be 16 different sites available or testbed offerings available across the HVM Catapult, across 8 locations. The map shows the 7 locations of HVM Catapult centres, plus we have one in Liverpool as well. We have 2 of these, a factory in a box, one virtual and one physical location, covering a range of sectors, a range of manufacturing technologies, and a range of geographies. And these are not explicitly aimed at sustainable manufacturing, but will play a big role in looking at where digital can address net zero and sustainable manufacturing challenges. So where next? Come and please build your strategies, seek help in understanding where you can decarbonise your factory, decarbonise your products, develop new business opportunities, trace supply chain emissions, or develop sustainable solutions. So for manufacturers or technology providers, please get in touch to understand where the HVM Catapult can support you and where Made Smarter innovation hubs can help you take the first steps. So please contact us at hvmcatapult.org.uk, on the hubs in particular at Made Smarter at hvmcatapult.org.uk, and please come and visit us and take any questions for me at the HVM Catapult stand during this Digital Manufacturing Week. I hope you have a great week. Thanks for listening, and I hope to follow up with many of you soon.
Every year, the High Value Manufacturing Catapult meets thousands of ambitious small businesses like yours who see an opportunity to make big gains. But it's not easy. The cost and effort needed to take an idea to market can be risky, especially for smaller companies. We're here to help. Whatever your size, we give you the power to transform the products you sell, the way you make them, and the skills of your workforce, improving your company's performance. Embrace innovation and get in touch today.